Yes, I'm going to present a small pilot study that we did in the Malodiapo and the Dihlabe municipalities in eastern parts of the country, estimating evapotranspiration. My name is Mogele Moeletsi. We are all aware of the importance of reference evapotranspiration, and the FAO 56 Penman-Montefiore equation has been widely utilized to estimate evapotranspiration. In our climate database, we actually use the equation to estimate reference evapotranspiration for a number of stations. I'll show you the distribution of our outdoor stations in South Africa, which are equipped with some of the sensors that can enable us to estimate evapotranspiration. The aim of this study is actually to look at the variability, seasonal and buff spatial of ET0, and also the contribution of thermodynamic and aerodynamic components in 3 stations in the Free State, and 2 stations in the Free State and 1 in KwaZulu-Natal. The 2 stations in the Free State are actually on a high altitude. Coming to the materials and methods, the Eastern Free State is actually got highly variable topography, ranging from 1.5 to 3,000 meters above sea level, and the climate is considered as humid subtropical, and also in the KZN, and also the one in Free State is actually semi-arid. The rainfall actually on average exceeds 500 millimeters, and we obtain relatively low temperatures in this part of the country. And the data that is used in this small study is actually obtained from 3 weather stations located, just like I said, in the Free State and also KwaZulu-Natal provinces. As you can see, the stations in the Free State are actually on a relatively high altitude, and that one in KZN is actually the lower altitude. This is the distribution of all the weather stations by the Agricultural Research Councils. This is an agro weather station, and for this study, we looked at these 2 weather stations, Bethlehem and also Harrismith in the Free State, and also we looked at Bergville, which is in the KwaZulu-Natal, and this is a relatively lower altitude station. This is a typical weather station, our agro weather station, that has got, as you can see, wind sensors there, and we have our radiation sensor, we have our temperature and humidity sensor in the gel screen, and also our rain gauge. And in some of the weather stations, we also have soil, water, and soil temperature probes that measures at 3 levels, 15, 30, and 60 centimeters. We use the basic Penman-Montefiore equation for this study. I'm sure you are all aware of that. And these are some of the parameters, equations for the parameters that we used. Coming to the results, if you look at Bergville, the left side is the vapor pressure difference, the annual vapor pressure difference, and for different months. And as you can see, it actually varies a lot during the day, and it peaks during when we actually have an early morning, it actually peaks and also goes down during sunset. And most importantly, the peak is around 12 to 16 hours during the day. And also looking at the months, we have high vapor pressure during the August to November period. This is also the same in terms of wind speed. The wind speed actually also peaks around 13 to 1500. And the period of August to November actually has the highest wind speed. That's why probably have also that translates to higher evapotranspiration during that period. The same applies to Bethlehem and to Harrismith as well, more or less the same scenarios. And looking at on an annual basis, on average, this is the variation of vapor pressure with on the right, and also if you look at on the left is our reference evapotranspiration, whereby we actually apportioned it in the contribution by the thermodynamic component and also the aerodynamic, the nighttime and daytime aerodynamic component. As you can see, the contribution of the radiance or the thermodynamic control is actually relatively higher here in Beckville. You see that in the next picture, whereby I'm talking about Bethlehem. Bethlehem is relatively lower in comparison with the aerodynamic component in this part of the. And then this is more or less the same. Bethlehem and Harrismith actually show more or less similar properties in terms of variability of the thermodynamic component and also that one of our aerodynamic component during the different parts of the year. And as you can see, also during August to September, we relatively have high evapotranspiration and also vapor pressure difference during that particular period. When we aggregate the data on a monthly basis, you can see as well more or less the same picture. You see the same picture, whereby we have high total evapotranspiration during the spring months, due to the fact that the winds are actually higher and also temperature is increasing during that particular time. And also relative humidity is relatively low in that particular time. This actually is shown in these three stations. And as well, most importantly, the average wind speed at Beckville, which is at a lower altitude, is relatively smaller. Is actually lower than that of these two stations in the Free State. Hence, we have we don't see the aerodynamic component here actually is more or less similar to that of a thermodynamic component in terms of contribution to ETO. Just in conclusion, the aerodynamic component of the pendulum motif therefore contributes